Thank you for coming. Welcome to our talk, Creating Ultra-Fast Real-Time Apps and Microservices with Java. Yeah, first of all, some words about myself. My name is Markus Kett. I'm living in Bavaria, and I'm working with Java and Java teams since 2001, and responsible for as a product manager for web design software called XDEV, XPage software, and a Java IDE called XDEV. And currently I'm working on an Eclipse distribution called RapidClipse. It's completely free, and it's a little bit a kind of visual basic for Java. And I also was responsible for a query language called JPA SQL, and I'm editor-in-chief for a German Java magazine called Java Pro. It's the first free Java magazine in Germany, and I'm also co-organizer of a Java conference called JCon in Düsseldorf. This is our magazine. It's a community magazine, and a lot of Java user group members are writing for this magazine, and this is the conference, and we have a special offer for all Oracle Code attendees. So if you like to attend JCon conference, you can get tickets for free. You only have to send me an email, and I will send you a ticket code. So please take a picture, and if you're interested, write me a mail. About the agenda, first of all, I would like to tell you something about our challenges in a huge project for the furniture industry. And then I want to talk about a little bit about the problems about databases of today, and what's about NoSQL databases, and then about some different in-memory computing technologies. And then I will introduce to you a new approach and showing some code and a live demo. In 2013, we got a huge project for the furniture industry. We had to develop a B2B platform. And the company used the Cache database. Who of you know Cache? That's object relational database. No one? Okay. And later we tried out Microsoft SQL Server, and it was too slow. And we also had the challenges. They wanted to have a SOA architecture, then later we called it microservices. And we had a team with some Java enterprise developers, and maybe 5 to 6 4GL developers with not much Java experience, and some Cache developers. Yeah. And the time frame was 3 years. And the end result was a real disaster, because we had a lot of troubles, and the reason was databases and JPA. Who of you are experts in SQL, for example? SQL, okay. And who of you use JPA? Okay. Good. The problem of the databases of today, what was our opinion, is the technology is from the 1960s, from the late 1960s or the early 1970s. The problem is it was built for the then art of computer technology and program languages and the use cases, and Java came up 25 years later with a completely new concepts And the end result is Java and the old databases are not compatible. The end result is we have a lot of problems while the runtime and also while the development time. Yeah, what was the problem before the database management system came up? We had multi-user applications, and all clients wanted to write data in a file, so we had concurrent writes and inconsistent data and a lot of errors. So what can solve the problem was the database management system which came up. So the idea was a central server managing all the concurrency problems and storing the data in a file. This was the basic idea. Of course, the databases were extremely successful, and so we got a lot of more concepts. For example, really business logic, for example, PL/SQL, writing stored procedures, triggers, and constraints, and so on. And we got a query language called SQL. Then the database server provides us a user management, import and export interfaces, and a lot of more features and a storage engine. And this was working really great, and this was really necessary. But when Java came up in 1995, we came in trouble, because now in Java we have completely different program language. We have object-oriented programming. We have a completely different data structure. And the business logic is written in with classes and methods. And concurrency problems we have to solve for ourselves. In our project, all concurrency problems were not solved by JPA, so we had to care for the concurrency problems for ourselves. Yeah, we write our own user management and so on. If we need interfaces, import-export interfaces, then we use web services and so on. So you have a lot of competing technologies. And so today, the Java server is the boss, but the only thing missing in Java is a storage function, a function for storing data. And so we had the idea of choosing a database server for storing data, and this is the reason why we have now a three-tier architecture with Java and a database server in the backend, and with a lot of computing concepts. But the problem is Java and databases are not compatible. But JPA has to solve this problem, and so this is a state-of-the-art architecture. We have the JPA stuff and a database server. Yeah, in Java we use object graphs. In relational databases we use table and relations, and so we need a mapping between both data structure. And this is called object relational mapping. And it's standard since about 11 years now. And one of the most important frameworks here is Hibernate or Eclipse Link or OpenJPA. While the runtime, here's the problem, it takes a lot of computing time. The object relational mapping takes a lot of computing time behind the scenes, and yeah, end result is up to 60% performance loss. So it's dramatic. For the developers, we always have troubles with computing concepts. We have the troubles with two different data models, double effort while programming. And JPA is very complicated. In our project, we had the problem that the 4GL developer were not able to use JPA. We were able to teach them Java in 2 years, but using JPA, it was not possible. It was always a disaster. So we had, and it's not fast enough, so we need an additional caching strategy for that. Then while programming, we mix code. We have the Java code and we have the SQL strings inside the Java code. So this is really ugly. And yeah, it's high complex and always a source of errors. So most errors we had were a lot of memory leaks. Maybe you know that problem. So it was not really fun for us. There are further challenges of database systems of today. Conventional database store the data on a hard disk, and the hard disk was high-tech in 1960 and 1970, but today it's a very slow component. RAM is much faster. Then we have the bottleneck. The classic database servers, they store the data on an independent machine in a file on an independent running machine. So we have that network communication always, and it takes tremendous computing time and tremendous loss of performance is the result. Then it's well known that SQL databases have a lot of problems with complex data structure. But today, we always have complex data structures, or in most projects. Especially in our project, we had extremely complex data structures. And the Java object graph actually is always very complex. So it's a problem for SQL databases. Then the most database servers are too big for mobile devices or embedded use or microservices. For us, it was always a lot of overhead when we had to use JPA together with microservices only to store some metadata, for example. So it didn't work very well for us. Yeah, what's about modern NoSQL databases? They changed something. They changed the data structure. We have now key value, documents, for example, JSON. It's cool for JavaScript developers. We have graph databases. We have object-oriented databases, and so on and so on. But the point is, these data structures are always different from the Java object graph. And so you always have the mapping between the Java object model and the native data structure of the NoSQL database. So actually, it worked not really good for us. And then we have all these computing concepts also in NoSQL databases. For example, their own query languages. They provide us a user management, they provide us import and export interfaces, and the same competing concepts we have already in Java. But the only thing missing in Java is a storage engine. So for us it was not suitable to use a NoSQL database. They were a little bit faster than the classic databases, but behind the scenes you have always the mapping, and it takes also computing time. You have double data models, and you have to learn, for example, a different query language, additional overhead and effort. So this was not a good solution for us. So we looked for in-memory technologies, and when we talk about in-memory, then you should have a lot of memory, of course. So ideal case is having enough memory. It depends only on the price, on the cost. And why in memory? RAM is very fast, so about 100,000 times faster than hard disk access, and RAM is much cheaper than ever before today. So we have here in this area 3 different approaches. We have the data caches. All of you who have ever used JPA use a second level cache, I guess. So we had this data cache, for example, EH cache or mem cache and so on for a Hibernate second level cache. And the bigger the RAM, the faster the app. So this is very clear. But behind the scenes, there is the data are stored in the RAM, but there are also object relational mapping behind the scenes. So this takes a lot of computing time, and you can have much memory as you like. You always have the performance loss because of the object relational mapping. Then we have the in-memory databases. And we checked out the in-memory databases. And here the entire database management system runs in the RAM, in the memory, and it's deployed together with the application in the middle tier. So we have no network bottleneck here. So this approach is very faster than the data caches, mostly. It depends on what you're developing, of course. But the backup strategy here is a classic database. So here's the same problem, the object relational mapping behind the scenes. And we have additional complexity because we have now 2 different database management systems, one in-memory and one classic. So this was also not a really good approach for us. And then we have the in-memory data grids. And it's also interesting because here is, the memory of your application is spread over a lot of servers by the grid. This works really cool. But here also, behind the scenes, you have a backup strategy. It's a conventional database system, and we need the object relational mapping behind the scenes. So it's always the same. Yeah, it's because of the engine we use. We use the SQL technology. So it's always the same. Then we talked with some Oracle guys, and they were just kidding and told us, hey, use a pure Java application running in the cloud without any database system. So you have memory enough, and it's secure. So you don't need any database system behind the scenes. They were just kidding, but we thought about it, and this concept would be great, because no more competing concepts, only one data model, only a Java object graph, designing an object model completely free would be great. No JPA stuff and so on. No query languages. Pure Java queries. Searching on object graph. Yeah, it's a dream world, and all queries are much faster because they are executed in the memory, and when they are executed in the memory, then the JIT compiler accelerates all queries up to 1,000 times faster than any other query language we have with classic database systems, and a super simple architecture. Completely crazy, because okay, what is the problem when the server crashes, when the cloud crashes? The Oracle guys told us that will never happen, that our cloud crashes. It's high available, so trust us. But then we had an idea. What's about the storage engine for the JVM? And we had a prototype, and so we developed this this prototype for this project. And the idea was storing data only, no computing concepts like database servers provide, no additional data model, no more mapping, no more query languages, and so on. Only pure Java, only storing a Java object graph. So we canceled all these concepts of a classic database system, and we extended the Java JVM with a storage engine. And what provides Jetstream, the project codename was Jetstream, and it is a storage engine for writing, reading, and caching data. The data structure is a native Java object graph. For the very first time, really a native Java object graph, storing for storing any Java object without any annotations or XML configurations or so on. And no more mapping, only one data model, and it's only a tiny Java API. How does this work? Jetstream reads the entire object graph from the RAM, from the memory, and stores the data directly into a file on a disk. So it's a one-to-one copy of the entire object graph stored on the disk. And the write strategy here is appending the changes only, not snapshots of the entire object graph, of course. Only the changes are stored into the file. And when it reads data, then the data are read from the file and stored directly back into the RAM. And here we have two strategies, eager loading or lazy loading, and this is similar to JPA. Then queries. All data are stored in the memory, of course. And if you want to query data, then we only have to search on the object graph. And yeah, we needn't to develop another query language, so you can use pure Java Stream API for that, for example. And we have no more mapping behind the scenes, and the JIT compiler optimization by the JVM accelerates your queries. Yeah, it's really fast, faster than any in-memory databases, for example. And the ideal case here is having enough memory, of course. Then Jetstream would be only a backup strategy for storing the object graph. But if you have not enough memory, then it works a little bit similar than Hibernate. You can load nodes or lazy when needed, and when it's not enough memory, then yeah, you can load it lazy. The benefits then are clear. you can develop a pure Java application, and this is what we did in our project. The entire B2B platform is a pure Java application without any JPA stuff. We only used Java for that, no more query languages, only Java. We only have one data model. This was the Java object graph. And the advantage here is we were able to design our object graph as we wanted to design it, not flat JPA object model, but really perfect, elegant Java object model. We didn't need any JPA stuff, so it was very easy for the 4GL developers to use it. And we have only type-safe Java code. And so it worked really great for our real-time features and for using it for the apps and for the microservices. So it was no more overhead when a microservice has to store data. There's a question?
Yeah, quick question. Is Jetstream just a single JVM solution, or do you have a strategy for sharing data across JVMs horizontally?
Currently, it's a single strategy, but we plan to share it. Yes. So here is the architecture of the storage stack. We have to develop an object serialization. We were not able to use the Java object serialization. We had a lot of troubles with that, so we did it for ourselves. We had a lazy loading strategy and a garbage collector for operating on a file. So it's nearly the same stuff. What the JVM has to do on the memory, he has to develop for doing it on a file store, on a plain file store. Behind the scenes there are a lot of more things, but this is not really important here. Backup functions are available, and a lot of strategies for example, when you use different applications, want to have access on the same file store and so on. Okay, let's see some code. It's very easy to include it in any Java application. Here are the Maven Dependencies, and the only thing we need is a Jetstream instance. This is the first step. So this is easy. Then here you can design your own Java model as you like. Here's a very simple example. No annotations and no XML configurations and so on. Then we need a root object. It's similar to a tree in Swing, for example. And then we can add any Java object to our root object and store it with only one method. It's called store required, and that's it. That's all. And everything is done by the engine behind the scenes. Here's an example for lazy loading. So it's also very easy to use. And queries, yeah, you can use Java Stream API for querying your data. This is not Jetstream, this is pure Java. So Jetstream is really only the storage engine for storing the object graph and loading nodes, lazy or eager. Quick demo. It's really a very simple demo. I generated 50,000 records in a MySQL database. It's a normal installed MySQL database, and it took about 100,000 milliseconds. Then the same with the Cassandra database. Cassandra is really faster, 4,000 milliseconds. With Jetstream, it takes 385 milliseconds. Then we can query the data. This is a little bit more interesting. Reading data from the database. And here we have really simple data structures, not complex data. We have 5,500 milliseconds with MySQL. I guess Cassandra will a little bit faster. 340 milliseconds, and with Jetstream we have about 4 milliseconds. So this is not fair, because in JPA we use a second level cache, of course. So when we repeat this, again reading from the second level cache, then MySQL gets faster and faster. And some of our developers told us always, yeah, with the second level cache, MySQL is also a memory database, because the data are read from the memory, but it's not as fast as Cassandra. And now, when I repeat the reading with Jetstream, then the JIT compiler starts his work. So it's much faster, because this is not Jetstream, this is the JVM, and it's the most it's the fastest thing we can use in Java is of course querying our object graph in the memory, and the JVM will always win. And yeah, this is the reason why you can develop ultra-fast applications with pure Java, and the only thing you need actually is a storage engine for storing your data with no complexity behind the scenes, which every Java programmer can use. And with Jetstream, for us, it was possible to complete our project in time, and it runs very well, and it's one of our biggest customers. And yeah, most question is, when should I use Jetstream? When can I use Jetstream? Because all databases they take a special area. For example, graph databases, they tell you if you have complex data for science, for example, then you can use a graph database. Then it's good. Maybe for other things, it's not really good. But when would you use a storage engine for storing your object graph? When do you use Java objects in Java? Always, don't you? So we say when you use Java object, then you can store your object graph with Jetstream. So you can combine it with all Java frameworks, with all cloud frameworks. It's only a Java API which cares for storing the object graph, not more, not less. And it's very good for microservices, storing metadata, for example, or for mobile devices. Requirements, it runs where you have a JVM. Java version 8 is needed, and these companies are using Jetstream DB already. And this here is the company with the the project we developed. Yeah, and Jetstream can be used as a storage engine for NoSQL database also. So you can set on top of Jetstream your own NoSQL database, for example. Yeah, you can download Jetstream from the website, and currently it's beta, but it's in productive use since 2 years in the furniture industry and at different companies. And in some weeks, the final release will be launched. And if you have any questions, you can write me an email or contact me on LinkedIn. I will answer you quickly. So, if you have any questions?
How do you deal with object versioning?
Yeah, this was one of the most trickiest things. Currently, in the first version, we have an export. You can change your data model, and then you have a CSV import exporter, and then it's refactored automatically while the runtime. And in the second version, we have an engine which it's done completely automatically than by the runtime. So it's all done by the engine. And this is one of the most important things, because this is a problem which the old object relational databases could not solve. And the most people heard about Jetstream, they think it's an object relational database, and they mostly the most reaction is, yeah, the object relational databases had these problems when the object model is changed. So this problem is solved by Jetstream. And I think this is a T-shirt. Other questions? You like T-shirts? Yes, please.
How the file storage works behind the scenes, when does it take place?
Sorry?
How the file storage works behind the scenes and how it takes place. Does it happen immediately, or there's a scheduling of that?
The file storage, it's a plain file storage, and the data are stored in human readable format. And so the only thing what is necessary is your Java application can only have no, this is not true. It's necessary that your JVM has one storage, but the storage can be everywhere. So that's your decision. Yeah. You like a T-shirt?
Are there any limitations in concurrency?
Sorry?
Are there any concurrency limitations for Jetstream?
Yeah, this is also an important thing. Concurrency, you have to care for concurrency for your own. This maybe could be most tricky thing of Jetstream, because if you're not experienced with handling concurrency, it could be a problem for you as a developer. If this is not a problem, then if this is a problem for you, then we developing an entity framework right now for handling these concurrency problems a little bit better. It comes in about 3 or 4 months, so then it's easier. Yeah. T-shirt? Yes?
Do you guys handle memory overflow, like overflowing to the disk when you can't fit the data in memory?
Yeah. So the engine cares about memory overflow. So you get the information if something happens which is bad for your memory situation. And the garbage collector handles all your inactive nodes while on the memory, and the garbage collector for Jetstream does the same job on the file. So
We have a smaller size.
a smaller size. What is it? It's this S. Extra large. M.
I want smaller. Medium.
This is medium is the smallest.
Yeah, thank you.
Extra large is good for you? No. Oh my goodness.
Thank you very much.
It's for the US market. The programmers in America, they, you know, an L, large. Okay. Sorry, he was first.
JetStream interact with any transaction packages? So can it participate in a transaction, for example?
Yeah. When Jetstream stores data, then it's always appended to the file storage. So actually, this is a transaction, and
I meant a global transaction with other transactional resources like a JMS API.
yeah, you can use it.
You can.
Yeah, you can use a large T-shirt.
Oh yeah.
Yeah,
A lot of the better. Thank you.
XL, you're also available. Yes. Yeah.
Thank you. I'll throw this to the next.
I only can take 7 questions because I have 7 shirts. Yes.
JetStream is written in Java, is it?
Yeah, it's pure Java.
Yeah. How soon can you incorporate other languages, other programming languages into JetStream?
Yeah, this is currently this is only possible with web services. You can write web services and communicate with any other application.
Yeah. For example, like if you want to, because if you want to write, you're writing in C#.
Yeah.
Or C++.
Yeah.
And you want to use JetStream, they're not compatible, is it?
Yeah, you cannot include Jetstream into a C# application. This is not possible. We are working on a server version, but this is the server version would be great for developers using different program languages, but then we have the network bottleneck also with the Jetstream server. So there are a lot of benefits you don't have when you use a Jetstream server. It comes maybe in 1 year, so this is our plan. Yeah, then we also have the network bottleneck. Currently, it's installed. It's deployed directly in the same process as your application in the same JVM. So there is no network bottleneck. Yeah. You like a T-shirt?
Yeah.
Oh, yeah.
Because you're writing the file in a human readable format, for your large objects, wouldn't it be better to compress it so that you're not using up so much file space? You've got a lot of transactions.
Do you think there could be it could be too big
Only for images, for example.
for images? Yeah, okay. This is always the same problem. You can store it. You want to store it directly in the same in the same file. Maybe it's not a good plan. A better strategy would be to store it in a different directory, and you store the path in the file store. The reference would be better. Yeah. You can do whatever you want. You're the programmer. You can do that. You can store blobs, but yeah, it's not the best thing. Yeah. Your T-shirt, of course. Anybody else? Yeah.
Sorry, coming at this from kind of a database developer's perspective, I'm trying to understand how I could use this instead of Oracle, for
Yeah, mass. Okay, this is the same problem as database migration with another database system. Mass data migration is always a challenge.
So is there like an interactive mode, for example, outside of your Java application where you can interact with the data? I mean, in database, I just do an update.
It's difficult to understand. Sorry.
Oh, sorry. So if I were in a normal DBMS, I would just issue an update statement to do data migration or merge or something like that. How would I approach this in JetStream? Would I have to create a new Java application to do that, or?
Oh no! If you have, if you want to update data, then you update your data directly in the RAM, in the memory, on your object graph, and then the engine stores this data directly into the file storage. So everything you do on your object graph is a changing of your data. It's a changing of your database. Yeah. Are we late? The next speaker is next speaker waiting, or do we have some time? Okay. Hey, I've some T-shirts here. Yeah. No. No T-shirt. I have some skirt.
There was the comparison between different DBs. How many objects were used for the comparison?
How many objects?
Yeah.
Here in my example.
Yeah. For the different times, like there was Cassandra.
50,000 records and strings only, no complex data structure, because if I use a more complex data structure, then JetStream is even faster. So yeah, because the SQL joins are very slow, and JetStream, actually this is not JetStream, actually this is Java VM, and so the classic databases wouldn't have any chance to win. This is the reason why I used only plain strings. Yeah. Yeah.
So this is open source project, or even though it's free to use?
There's a free version, and no licensing planned currently. It's free because it's not final released, and when the final release is here, then we will provide a community edition and some enterprise stuff for clustering and for replication. So this is the plan. Yeah.
Are you going to provide a read replica feature, or is it going to be a process that has to be done with the basis by the sysadmin? And out of the box read replica feature it's going to provide?
A replication?
Yes.
Yeah, currently you can use any technology, any framework which provides this stuff. We are going to develop such replication and clustering stuff, but it's not done until now, and so you can use anything which works for Java, which is good for a Java application. So, yeah. Who likes the T-shirt? I only have 3.
Another question, thank you.
I can throw. And the last one, he was first. Thank you. Thank you.